Hope you are having a productive day. In this video, we will be deriving the kinematics equation S is equal to ut plus half at squared. So let's get right into it. So the first thing to note about the kinematics equations is that in order for them to work, acceleration must be constant, which means acceleration cannot change its magnitude or its direction. I will now explain what quantity each symbol will represent. V bars is going to represent average velocity, V is going to represent final velocity, U is going to represent initial velocity, displacement will be represented by S, time will be represented by T, and acceleration will be represented by A. It is important to note that there is a difference between average velocity and final velocity. So the first equation, average velocity is equivalent to displacement divided by time. By definition, average velocity is equal to the final position minus the initial position divided by the time taken. Final position minus initial position is going to be equivalent to displacement, hence why we have displacement over time. The second equation, average velocity is equal to final velocity plus initial velocity divided by 2. Another equation for average velocity. We get this equation for average velocity because acceleration is constant, meaning the average velocity is going to be midway between the final and initial velocity, since velocity is changing by the same amount every second. In order to find a number that is midway between two numbers, you add those numbers up and then divide them by 2. You can test it for yourself. Try to find a number that's midway between 1 and 9, and you'll end up with 5. The third equation will be acceleration being equal to final velocity minus initial velocity divided by time. By definition, acceleration is the rate of change of velocity. Change in velocity is equal to final velocity minus initial velocity, and a rate in physics is something divided by time. We can derive the other two kinematics equations using these three equations. So as long as you remember these three equations, you can derive the other two more complex looking kinematics equations. In this video, we will be deriving one of the other kinematics equations. So let's get right to it. Here we have the three basic equations again. We will transpose and substitute where necessary in order to get the final equation. You will see what I mean as you watch on. So we're going to write back equation number 1, which is the equation for average velocity, one of them. Now we're going to transpose to make S the subject of the formula. In order to do that, all we have to do is multiply both sides of the equation by time. The times on the right side of the equation cancel out, and we're left with S is equal to average velocity times time. Now we can notice something with this equation. It has average velocity in it. Because it has average velocity in it, we can substitute average velocity from equation number 2 into this equation. When we do that, we get S is equal to V plus U divided by 2 times time. Before we go any further, let us rearrange equation 3 to make V the subject. And we're doing this because it helps to derive the final equation. So first thing that we're going to do in this equation is that we're going to multiply both sides by time. The times on the right side of the equation cancel out, and we're left with AT is equal to V minus U. Now we're going to add U to both sides of the equation. The U's on the right side of the equation cancel out to give 0, and the left side of the equation has the U added to the AT. So the final equation is going to read V is equal to U plus AT. Now let's write back some of those equations. And now we are going to substitute some values. So in the equation where we have S is equal to V plus U divided by 2 times time, we are going to substitute the V for U plus AT. We will get S is equal to U plus AT plus U divided by 2 times time. Now we will add the U's in the numerator to get 2U plus AT divided by 2 times time. Now we are going to divide the numerator by the denominator. So 2u divided by 2 is going to just give u, where at divided by 2 is going to give half at. So we are left with the equation s is equal to u plus half at times time. Now we're going to expand by multiplying the terms in the bracket by the term outside of the bracket. When we do that, we're going to be left with s is equal to ut, which is u times t, plus half at squared, which is half at times t. And now you can see we have arrived at the final equation, s is equal to ut plus half at squared. This final equation can be very useful as it allows you to find time even when you do not know the final velocity. It is important to note that the quadratic formula is a very useful tool when working with this equation, as it will allow you to solve for time. That's going to be it for this video. Thank you for watching, and I hope you've learned something.